Hello all, today in this video I'm going to make a demo of email classification, that is email detection, spam detection by using the email spam dataset which we acquired from Gaggle. This dataset you can see it is you can just check email spam detection dataset in Gaggle. It will be easily available. So in this work we have worked with the random forest. In the other code, in the previous upcoming codes, we will be working with some other algorithms too, and also we will make a comparison. So for that, initially we are importing the libraries like pandas, matplotlib. Then from sklearn we have imported the train test split function. This function will be using to split our data set with using x and y variable into x train, y train, x test and y test variable. And then we have imported our random forest library, and also in this code we are going to display an ROC curve. For that, up along with classification report, confusion matrix and accuracy score, etc. So for that we have just made to declare that libraries also. Then we are just calling our data set by using the or the CSV function. So this is the data set which we have used. It is having more than 3002 columns. Among this, 3001 columns will be used as x variable, and the last first column will be used as the y variable. So then we are getting the info of the data set, whether it is an integer or what. So those details is given over here. Here you can see the 3001 entries are integer and one is then object. So which is the object is email number is object. Here itself you can notice that email number is an object and every one are integers. Then we are checking whether our data set is having any null entries. No, it is not having null entries. Then we are splitting our data set into x variable and y variable. As I said, in the x variable we are choosing only the variables apart from the last entries, and the last entry is only chosen as the y variable. Then we are splitting our data set into x train, x test, y train and y test by using a test size of 0.25. That is 25% will be taken for testing and the remaining 75% will be taken for training. Then we are declaring a random forest machine learning algorithm. For that, initially we have declared the library of the random forest classifier that we have used over here by using a random state is equal to 4. Then we are training our function by training our data by using the fit function and with the variables x train and y train, and then we are going to print our results for trained results. For that we are using the predict function for x train and the predict function probability, that is for x train, and then we are declaring its confusion matrix, accuracy score or ROC AUC for train. And then we are splitting the printing or testing results. For that, in place of x train we will be using x test data, and same we are going to display those values. So here you can see the values of the random forest is given over here. You can see that our random forest algorithm has got an accuracy score of 100, both for ROC also 100 and accuracy is also 100. The confusion matrix for train and set is also, you can see what is the difference, because in training we are using nearly 75% of the data, but in testing we are using only 25% of the data. So obviously there will be some difference with the confusion matrix. Accuracy score also it's having some difference. ROC AUC curve also different. There is some difference. So for a better machine learning model or whatever model, you will be saying like once when the testing accuracy or testing score is better than the training score, it will be saying it's a better system. In that case we can't consider this random forest as the best model, because in this the training score is only high when compared to the testing score, but it's not showing much variation, because in some cases it will show more than a 30% difference, but here it's showing only 3 to 2% difference. So it's but still it's not a good system. Then I said that we are declaring an ROC curve. So for that we are just getting the FPR, that is false positive rate, true positive rate values, and then by using those we are just plotting a graph. So this is the graph of the ROC curve in this random forest algorithm we have designed. In the next video, we will be working with some other algorithm, and we will just make an comparison with the previous algorithm, that is the random forest algorithm we have made now, and we will just make an conclusion that which algorithm will provide a better results. Thank you.